Hey, welcome to another lesson with me, Ms. Madsen. Today we're going to be finding the surface area. Surface area. Area should sound very familiar, right? But the surface area, and we're going to find them of cubes and prisms. You know what cubes and prisms are from last lesson. As a reminder, a cube is just a square, a six-sided square that's three-dimensional, right? And a prism is rectangular and also has six sides. So one thing we can do is we can look, and the area, surface area, is just the area of everything on the surface, not what's inside, but like the wrapping. So for example, let's get a little bit bigger. Oops, come on. For example, this is a pack of paper, okay, kind of like a present. It's wrapped. What surface area is how much paper, how much wrapping paper is this? How much wrapping paper do I need? I'm not asking how many papers are inside, right? I'm talking about the outside. The surface of something is the outside of it. So I literally want to know how much surface is showing in this rectangular prism. That's what surface area means. And the way we do that is just by looking at this shape right here and saying, oh, that's a rectangle. That's a rectangle. That's a rectangle. I know that the formula for rectangles is area equals base times height. So that's what we're doing today. We're working with shapes that are rectangles or squares and doing base times height with all of it. Okay, so looking at this first cube, if I were to flatten this cube out, we would see 6 squares that were all exactly the same shape, wouldn't we? We'd see the front, the top. Whoa, what happened there? Oh, there it is. We'd see the bottom, we'd see the sides, and we'd see the back. And every single one of these would be the exact same area, right? So if we just looked at the center one, it's 5 centimeters by 5 centimeters. You're making me really nervous by standing there.
Well, I have
Come
a question.
say hi.
I have a question.
Is it about math?
No.
Area equals base times height. Base is 5, height is 5. We've got 25 centimeters. Does it need to be a question that needs to be asked right now, or can you wait? Why? What is it?
Where's my piano books? They were in the van.
They're in the van still somewhere.
Where?
Go look in the back. Or down in the middle.
I tried them.
Okay. Okay, so we know that that square right there is 25 centimeters squared. And there's 1, 2, 3, 4, 5, 6. There's 6 of those. So let's times it by 6. And we get 150. So the surface area is 150 centimeters squared. The whole, like, if we wanted to wrap it let's say it was a present, if we wanted to wrap it with the least amount of wrapping paper as possible, we would need exactly 150 square centimeters of wrapping paper. That's what surface area is, okay? So let's see if you can do it now. We've got a cube right here, and all of the sides are 7 centimeters. Well, base times height would be 7 times 7, which is 49. And let's times that 49 by 6 and get 294 inches squared. That is, for a cube, that's all you have to do to find the surface area. Okay, let's look at, though, what if you have a rectangular prism that's not a cube? Like this, right? Where this side is different than this side, and this side is, like, we have different sides here. Okay, so we can't times by 6 because they're not all 6 sides the same. But maybe what you can notice is that the front is the same as the back. The sides are also the same, and the front, the top and the bottom are also the same. That's my trick for finding the surface area of any other rectangular prism. Okay, so still can't find them. They're in the van somewhere.
I've checked every spot.
Sorry, you're gonna have to help. I'll have to help you when I get done. But if I find it and you don't, you owe me. It's gonna be on film. You owe me $20. If I find them and you don't, $20.
That's harsh.
Okay.
Usually it's like $1.
Go. All right. So as we were looking at, we could see that the front of a rectangular prism has the exact same dimensions as the back. So what I like to do is I like to go do like FB, meaning front back. And it's a rectangle, so we're doing base times height. 3 is the base right there. Do you see how it's labeled? So it's going to be 3 times. Now here's the tricky part. Sometimes the heights or the bases aren't like specifically labeled. So what you have to do is you have to find a parallel line that is the exact same distance. Let me show you what I mean. So this is the height of the front. It's the same as the height in the back, isn't it? And that height is labeled. So I can go 3 times 8 and get 24. Okay, now that's just the front. That was this right here. If I want to do both sides, the only thing I have to do is then times it by 2, and I get 48 meters squared. That's for the front and the back of that rectangular prism. Okay, the next thing I'm going to look at, I usually like to look at the sides. This side is the exact same dimension as the other side, right? And this is 5, that is 8, so 5 times 8 equals 40. That's for one side. Double it so I can take into account both sides. So that gives me 80 meters squared. Okay, the only thing we haven't looked at yet is the top and the bottom. There's my top, there's my bottom. We can see that the dimensions for the top and the bottom is 3 times 5, which is 15. Double it because there's a top and a bottom. That gives me 30. The last step is to add it all together, and that will now give me the surface area of all of it. Okay, so a couple tricks with this. If you don't like thinking front, back, side, side, top, bottom, then what you can look at is the 8. One of the sides is going to be used twice. Another side is going to be used twice. And numbers will be used. So the 3 gets times with the 8, and the 3 gets times with the 5. The 5 gets times with the 8. The 5 gets times with the 3. The 8 gets times with the okay. But if that's like, well, that didn't make any sense, then do it the front, back, side, side, top, bottom ways. Okay. Okay. Let's try it again. This one looks more like my packet papers here, huh? It's kind of flat on the bottom, on the top and bottom. Okay. So, but I'm going to do the exact same thing. I'm going to go front and back. And this could be my front, or this could be my front, however you want to think of it. Just make sure that you do all the different sides. Okay, so my front is, this is 9. Now, the height of the front is not labeled, but if I were to look back here at the back, the height for the back is labeled. So that's 3 times 9. It gives me 27. I'm going to times it by 2 because it's a front and a back. Then if I look at my sides, there's a side there. This side is kind of hidden, but it is there. So my sides are 7 and 3, which is 21. Double that and I get 42. Okay. And then my top and my bottom. Here's my top. And my bottom is underneath where you can't see it. And the labels for that is there's a 7 and there's a 9. That gives me 63 times 2 would be 126. Okay. Now what I was saying earlier is 7 got times with the 3, 7 also got times with the 9, and then 3 got times with the 9. So all of them took a turn being times with each other. All right, let's add all them up. And I get 54 plus 42 plus 126. 222 centimeters squared. Okay, so hopefully that gives you enough of practice. So if you can visualize it, just make sure you find the area of the front, times it by 2 because there's 2 of them. Find the area of the sides, times it by 2, because there's 2 of them. Find the area of the top, and times it by 2, because there's also the bottom. Good luck, guys. See you later.